All right, so we are recording on previous discussion. We were going over just the Hugging Face Transformers library. We're still just doing inference, but I want us to do this and kind of familiarize ourselves a little bit with Hugging Face Transformers before we start trying to fine tune, which is the first goal that we need to have, right? We need to fine tune something for some specific task. Okay. And also, if you remember, I was talking about RLHF, where we're going to take a model, take some text, and it's going to give us a score of something. So I also want to touch on that today, which is key to one of the second assignment. So one thing to think about is you could actually train your own BERT to be a reward model. And the way that you would do it is you would fine tune a BERT to do the specific task that you want, but that's much more difficult, right? An easier solution is just to find, because we have such a big resource such as Hugging Face, you can say to yourself, they may already have that reward BERT, if you will. You see what I'm saying? So either way, we can just use one as inference, or we can train it ourselves. So in this case, basically we're using BERT models. And so the last thing we looked at was bias, how we can do the film mask function, give it something like mask, and it would give us the word that it thinks is the correct one. So now let's take a look at the next example. So this one is going to be a BERT for summarization. Okay, so we're going to do a simple summarization BERT. Obviously, you'll say, let's just do that with ChatGPT, but that's much more advanced. Here, we're kind of the different thing is we can play with these models and fine tune them a little bit more. So I'm going to do summarization here. Summarization. Let's take a look at a summarization BERT. We need some libraries, of course. This is actually a BART, which if it's a little bit different from a BERT. So you can see from transformers, auto model, pipeline again, BART tokenizer, BART for conditional generation, BART config. So let's run those libraries. Okay, that ran pretty fast actually. So now let's take a look at doing the summarization pipeline here. We'll copy. All right, so you can see we instantiate the summarizer with pipeline. We give it the task, a different task. We've done already like 2 additional tasks. And then this is summarization. The model, we use the BART for conditional generation. And then we say dot from pre-train, and we download from the hub, Hugging Face hub, this model. It's a distill BART CNN 12.6. So what this means usually is that there's a BART which is much bigger, much bigger, and it was trained and it's got a lot of great weights, but it's so big, might be 75 billion parameters, that it would be hard for it to run on our computers. So what people do is they have a smaller model similar to that BART, right? And they use the big one to train the little one. Do you see that? So basically you teach it, okay, here's the original text, here's the summarization, and you run those on the big model. And it essentially what it becomes is it becomes a tool for generating data. And then these pairs of data that are coming from a distill BART that are pretty good can be used to train a tiny one. You see this? So it's essentially like you're passing some of that knowledge that took a long time to get on the big model to the little one by essentially taking the big one, generate a whole bunch of data, give it to the little. You see that? So those models are called distill BART. So as an aside, for instance, right now with DeepSeek, there's, if you notice, a serious thing going on where OpenAI is saying that they gave big problems. They gave math problems to ChatGPT. ChatGPT solved them in a chain of thought approach. And then that data that was generated was collected and given to their model in a distilled fashion. Do you see that? So obviously that model became really good at solving math problems. Now I don't know. I actually am very impressed and very happy with DeepSeek, and I hope they did in fact do what they say they did, because it would be really great for everyone. And I still don't even see a problem with that, although it violates the policy of ChatGPT, unfortunately, where they've said you shouldn't use ChatGPT to distill knowledge. So it's a violation. But anyway, that's what distilling is, okay? Essentially take a really nice model like ChatGPT, have it solve things, prompt, response, get that, create a corpus data set, and then train your lesser model with that, and that's a distillation, okay? And so that happened, apparently that there's a big discussion about that. Here, what I can say then here is that there probably was a BART CNN 12 something, but that was too big. So then they created Distill BART, which essentially is a smaller footprint model, less bytes of data, and they used the data generated from the big one to train the little. Okay. So anyway, that's whenever you see that, that's what that means. So download the model. Then I have the BART tokenizer as usual, and we once again distill BART tokenizer. And then once we have those two things, we create our pipeline, and we give it, as you can see, the model and the tokenizer, and we just ask it to do the summarization. So I'm going to go ahead and run it. So it's thinking there. It's still doing that. So while it's doing that, I'm going to get the rest of the code. So I need some text. So essentially, this will try to summarize. Oh, gave me an error. Big error. Say could not connect to Hugging Face to load this file. Check out yeah, we were having issues with the connection, and unfortunately we do need these models. I wonder what's going on. Did you guys try this? Or it's running for you? Yeah, it's giving me an issue. Oh, that's too bad. Let me see. Let me try something else. Because I'm pretty sure I tested this one before I came to class and it worked. Let me try another model here. See, it's breaking exactly, I think, when I'm downloading the models. Let me see if it's just that one or if it's the whole Hugging Face that's. Pardon? The site, Hugging Face site is down? Yeah. I don't know what's going on. I think there's been a lot of cyber attacks because I saw this DeepSeek also got attacked. Anyway, let me try another one. If not, we're gonna have to switch gears here, because I don't have these models locally. Let's try another example, still using what is this use actually? This is going to use a BART model. And what we're gonna do is we're going to do classification, what they sometimes call few shot or zero shot classification. we basically use the language understanding of the model to look at a text and say, oh, this is one of these three classes that you asked me to think about. Okay, so this is called few shot classification, or zero shot, actually, I should say. So let me try this one. Libraries. I think my battery will die. So let's try. So basically, we would give it some text. We'll give it a list of classes, and this model will tell us which one of the classes it thinks it is. Again, this is crude or the precursors of prompt engineering. So let's define the labels and a sequence. So I'm going to France. So the label is this travel, cooking, or dancing, right? So that's kind of what we want to be able to do. So in the past, you had to create a model for doing this kind of classification. Now with these pre-trained models, they're so knowledgeable that you can actually just use them to do these kinds of things. And as I said, this is called zero-shot inference, I guess. So let's see, this is the part that might break, unfortunately, if the hub is down. So we need here, notice we are going to import something called an auto model for sequence classification. So it's a type of a classifier. So it's but without training. So this is something else that you could use for your rewards maybe, or at least to start working on it. So we want, this is from Facebook. So this was developed at Facebook, I suppose, before they were Meta. It's a BART large, so it's probably a big model. And we have the tokenizer. So let's see if these work. Okay, great. So this one worked. No issues. All right, so we have the model and the tokenizer. So then now let's go ahead and generate some parameters that it needs to have. Okay, I'm going to do that. So this is, again, because it's like prompt engineering or the precursors of that, they were trying to give structure to the text. So you're going to have the sequence, which is like the premise, and then what is the hypothesis? And the hypothesis is this example is this class. Do you guys see that? So that's the assumption and how they were trained. So they probably took those BART large MNLI and they said, okay, I'm going to build a classifier that always understands a sequence as a premise, and then another thing called the hypothesis. And then given that hypothesis, I can plug in variables in there and boom. And you can see it's like prompt engineering. So let's go ahead. It's like eventually I would say this capability somehow became embedded into the large language models like GPT-4, Llama 3. So, all right, so let's take a look at hypothesis here. You can see it essentially says this example is either travel, cooking, or dancing. So it needs to provide some kind of a distribution of probabilities of which one it is. And that's essentially what we want to do. So you guys could potentially use an approach like this for your reward function for your RLHF project, okay? Remember, you have a model. I said, you're going to build a GPT, and the reward model needs to provide the feedback. So you'll have options. Use one that already exists, build one such as this one with 0 shot or a few shot, or train one from scratch. Fine tune from scratch, but start at a pre-train. All right, so I did that part. Now let's go ahead and just encode it. So we're going to run through the model, but we're going to encode it first. So we use the tokenizer. It'll take the premise and the hypothesis, and it's going to return, so the encoded text as numbers. So we can take a look at it just by typing X there. X. You can see that's just numbers, the encoded values. And then now we make a call to NLI model. NLI model should be the model that we downloaded, right? The BERT MNLI that follows that particular structure. And we're going to give to it X, where we know that X is essentially made up of premise and hypothesis. Do you see that, guys? And so now we give that, and it's going to give us the result. So it ran fine. And now we have something called the logits, which usually like a probability distribution over classes. So we can just print them out. Right. So it says -2, 1.3, and 0.6. So it thinks it's about cooking. What do you guys think? Right, so that's the interpretation that I get out of this. Travel, cooking, or dancing. I look at this, and the highest value is 1.37. They're not soft-maxed, but that would be my interpretation of it. Let's do something, though. We can play with this a little bit more. So how do we make it more like the travel? I'm going to France to visit monuments, right? Whenever you see the word monuments, you usually think travel, on vacation. You guys understand what I'm doing? So I'm trying to help the model possibly shift to travel. Let's see if it works. Okay, it finished. That's good. If anything, it's more negative now, right? So it's minus 0.9, 1.0. Dancing. Well, I mean, it may not be great unless I'm missing something or you guys see anything. But essentially, the idea is here it's providing a vector over the 3 classes, and that should be correct. I guess I'm going to do this. I want it to be about travel. I'm going to travel to France to visit and travel. And you know what? I am travel. Go. All right, let's see. I mean, I've exaggerated. I put the word in there. Let's see if this actually makes it about travel, right? So let's see that. I'm not going to do that. Okay, it went up to 0.25, so at least we're in the right direction. All right. Do you guys see that? So it's not great. I mean, don't expect exceptional results from these things. And the thing that's going to give you the best is to use the better models, right? So Llama 3s, GPT 4s, etc. All right, but this is an example of the things that you can do, and it's called few shot or zero shot. Let's try another one. So the next one is, I think it's a sentiment classifier. Here we have, oh, this is actually metrics. So let's do this actually. So because we were talking about it with the paper, so we may need to install data sets. We'll see. So I'll label this as metrics, which actually this is something interesting, right? It shows you all the metrics that are available. Okay, so do that. All right, so data sets is not installed. So pip install data sets. Minute. All right. Finish. Okay, nothing. So it's successfully installed, so no errors. All right, so this is the transformers, probably library for this data set. So it's got metrics, list of metrics, list of data sets. So these are things that are definitely useful. I wonder if it's because, okay, let me refresh the kernel. Start this. Okay. The Jupyter notebook again. Desktop. Oh, wrong. 30. And I think we're here, right? All right, so we're going to try this again. Be this. It's giving me an error. I don't know if this has changed maybe. From data sets, import list metrics. This library may have changed. All right, anyway, let's just not run this one, but let's just see what was available at least. This may have been updated. So you can see some of the data sets that they had in here were these. Text probably about the Bible, Arabic speech corpus, Amazon polarity, Afrikaans, America's NLI, sarcasm data set. So they have basically essentially, um, you know, text data sets. I'll have to double check what it is now. The metrics you can see, which are the ones that are in the some traditional ones like accuracy, but there's something called the BERT score, for instance, and that's a variant. One of the in the beginning, the idea of creating a BERT model that can provide a score for a specific metric. I've mentioned this one, blue for translation, code eval for evaluation of coding, perplexity is another one. Some of the traditional ones like MAE, mean absolute error, and just metrics that people have created also. So lots of different metrics that are advanced. Probably I know that paper, the reference that I provided for you guys does talk about the BERT score. So that's probably the best resource, but you can see these metrics are implemented already in the Transformers library. And although I'm pretty sure it's in another data set or some other way that they do it, some other module. So I'll have to look into that. All right, the next example is sentiment analysis. So this one is actually a good example, hopefully it'll work, of what I was talking about with a reward model, right? So remember the idea of a reward model is with RLHF is you'd have a GPT, you give it text and it generates text. Then that text is used as input to another model that looks at it and provides some kind of score, right? So for instance, in sentiment, it'll say positive or negative. So we could use that to make text be more positive or more negative. So for instance, movie reviews, right? So general movie review, oh, the movie was so-and-so action movie. Use a positive reward model and give that feedback to the GPT, and what do you accomplish? Well, if you use positive, then, oh, that was a great movie. That was really great. I really like this movie. This movie is exciting. What if you want to make that GPT be more negative? Then you use that reward model, but to enforce the negative part of it. And so now it's going to say, no, that movie was terrible. I hated that movie. They shouldn't make movies like that, stuff like that. So you can see that's the idea with using RLHF with a GPT model. Now, some text might be neutral, and by having another reward function, it's making it grab towards more positive, more negative, depending on what the reward function is. So that reward function is key to achieving the objective. Do you see what I'm saying, guys? Make sense? All right. So hopefully this one will work, because this would be perfect. If it does, let's try it. It's a sentiment analysis, right? So I'm going to do here, and we'll kind of wrap up with this one and move on to the other topic. So I'm going to do sentiment analysis. Run. Right. So first thing, so from transformers, import pipeline, that has been working for us. Thinking. Then I'm going to make it into a pipeline for sentiment analysis. I do want to provide the text separately. Text 1. And I can just start with this one for now. Text 1. All right. So let's try it. So we love you. So that should be positive. Okay. And as you can see here, label positive, score 0.99, right? So that's the key to this kind of approach, to provide a reward signal to another GPT. So in RLHF, this text would have come from a GPT, and then it would go into this, and then this would provide that score, and then based on that, that would feed back into the updating the weights of the GPT through the RLHF process. So there's way more to that than what I'm saying. Kind of right now, I'm just giving you the overall idea. All right, so we see that. So tried that. And we got the same answer. We can repeat the exercise. And here what I think is happening is it's just showing one of the two. So we hate you. Obviously that should be negative. And you can see the highest score at 0.99 is negative, right? So that's kind of the feedback. Let's take this one. My cat likes you. All right, so sentiment analysis. My cat kind of likes you. So that's actually a student gave me this one, I remember, because it's kind of complicated, right? This is like likes, but kind of likes you. This like qualified and ambiguous and things like that. So for a human, at least. But for the model, it probably just looks at the word like and it's going that. And so it's actually not capturing the subtlety of this text. ChatGPT or something more advanced would probably say 80, not 99. Do you see where I'm going with this? But anyway, these are still useful though, at least at a higher level to serve as reward functions. So I'm going to the store. That's a pretty neutral one. We can definitely play with it. So we'll do it. Do it for sure. Hold off on that thought and we'll do it. So I'm going to the store. That's neither negative nor positive, although you could argue that somebody that goes to the store is doing well, so it's positive. So it's a 98. So it's negative actually. Why is that negative? Right? Why is that negative? But anyway, you can see that there. I mean, it's what it is. Okay. Bacon. Yeah, so bacon probably is the lowest one. It says it's negative. Yeah, so it says it's 89 actually, so much lower. Or a little bit lower. So it's not perfect, certainly, but that's kind of the idea. Now, when one thing about this is it's just returning either positive or negative. When you're if when you, and this is key, when you use this for your reward model or BERT model, you have to stick with one. Okay, you can't just like positive or negative. You have to say, I'm gonna go with positive because what I actually care about is that value. Is it 0.20 or 0.99? All right. So you'll have to make the choice whether you want to make your text be more positive or more negative by maximizing that output that comes out. So one good way of thinking about it is like this. I have this GPT and it's got a set of weights, right? And it produces some text. And that text comes out as you're trying to achieve the goal of negative. So it comes back at 0.20. So then you give that feedback to it. Hey, you got a 0.20 on this text. So it's like, oh, okay, that's bad. So I need to play with my weights again, does a thing, produces new text. The reward says, oh, yeah, it's negative, but 0.40. So it went up a little. So then it goes, and when it updates the weights through stochastic gradient descent, it's like, okay, I know which ones I need to change because they like these, not those, because I achieved 0.40. And it keeps doing that, and eventually it produces some text. The reward says 0.92 negative, so it knows I'm doing a good job. So that with the way that I'm updating the weights. Does that make sense? Okay, so that's reinforcement learning through human feedbacks and using this as a reward, a model. A BERT score in general is what most of you might use. All right, so I think that for today, that for these examples, I think that's good enough. Here's zero shot again. Let me, because this is another one that you could use for the reward. So let's try this one. I'm curious if this one will work. So this is because the first one didn't actually. But remember that the theme kind of with these is how to find reward models already available on the Hugging Face for RLHF, or maybe this one so that you can tweak it just a little bit. Because if you notice, this one does provide values there as well. So let's take a look. So I'm going to add, this is, I think, what was it, zero shot? Yeah, zero shot classification. So again, it's a type of prompting, zero shot. Okay. All right, so we got that one. So let me do this. I'm going to copy the libraries. We're going to use a BERT model again. So hopefully, I think it's the same one actually that we used before. That seems to have worked. CPU. Let's take a look at this one. All right, so pipeline zero shot classification, and we want to use this BART large MNLI. It's trying to load. Okay, it loaded, so that's good. So now so we've instantiated it actually, so hopefully it'll work. So good. So now let's do the following. So I have a sequence to classify, right? So this is, I like that tobacco rates have fallen. So again, if you're doing RLHF, two neural networks, you have your GPT, such as GPT-2, it generates some text, which is, I like the tobacco rates. I like that tobacco rates have fallen. So then now you would feed this into this classifier as your reward model, and it's going to give you, for one of the classes, a particular score, and then you optimize for that score, trying to maximize that reward essentially, which is what a lot of the loss function of RL, reinforcement learning, is actually about maximizing those rewards. So think of it as a max of R in its simplest form, where R is a reward. So here I have the candidate label. So basically you want to know if this text is cars, smoking, or pets, right? Do you see that? So let's go ahead and do that. Okay, so now we would take the classifier, give it the sequence to classify the candidate labels and produce a result. So it's processing it, it finished, okay? And then now we're just going to print the result, provide some kind of a dictionary. All right, so it said that 0.94, it's a car, 0.03 is smoking, 0.02 is smoking, so not great. Maybe the word fallen is related to cars, I don't know. You guys see? So now I do think this might still work though, because I had this idea. So this is a dictionary, right? So I'm just going to grab the scores from here. So scores. So I have the scores, and now I can just pick one of them. So for instance, I can just focus on one of them. So what I mean is if I do this, and if I just do 0, then it's just going to give me the 0.94, right? So I can always target one of the values that I want to optimize to make the language more be like that class. Do you guys see that? So let's run an example. We can ignore the other ones and still possibly maximize this value. And so let me try. So I'm going to grab one, let's say. And obviously the word is smoking, right? I want to pinpoint on smoking. So it's 0.03 currently, pretty low, but I want a GPT that maximizes this reward of 0.034. So then what does the GPT do? So it did this. I like that tobacco rates have fallen. That's not very tobacco-y or smoking related, right? So then you would give this feedback to the GPT, 0.034, and say, hey, that's pretty bad for smoking this. Do better. So then what does the GPT do? It goes in, changes its weight somehow, right? And then now it's going to generate a new text that says, I like that smoking tobacco yeah, rates, smoking tobacco is, I like that smoking tobacco is now considered bad and rates have fallen, something like that. So essentially, the GPT generated this text. So now let's see what the reward function says about it. Remember, the value before is 0.034. That's even worse, 0.00. Okay, I have a feeling this thing goes down instead of up. So let's just add smoking in there then. More smoking. Like, expect it to go up. So what I'm trying to do is the more I add the word smoking, the more I would expect the reward to go up. But it just goes down. So it almost seems like it's, yeah, go ahead. Sorry. So am I just misinterpreting this? Oh, you think smoking was the first one? How do you know? But here, when I provided it, is car smoking. So how did you figure that one out? It said it. Oh, okay, that's what cost us the problem before. So then, okay, so you're saying the first one. So then this one should be pretty high then. Ah, okay. So now let's do it. So thanks, Quentin. Your name, yeah. I always want to say Drucker, but yeah, it's Quentin. Sorry. All right. All right. So yeah, good catch. So what I need is just to print result. That's what I didn't have in the previous example. Smoking is the first one. Very good. Perfect. Good job. Thanks. There you go. And did we do it? We did the thing that we were trying to do, right? So I guess I'll repeat it, given that that's um, so let's start with the original one. Right? So I like that tobacco rates have fallen. So the score here should be 0.94. 0.94. So still pretty high and pretty accurate. Let's say now, let's try another one. I want to switch to, I don't want it to talk about smoking. I want it to talk more about pets. Or so then the GPT is currently just talking about this, but at some point it says, I like the tobacco rates have fallen. And actually, we need the value for this like this. Fallen. So let me run it. So one is what? 0.03? 0.03, right? So I want to bring that up by giving this reward back to the GPT. So I give it 0.03 now. That's pretty bad. So now I'm going to say, and I'm just, because we're running out of time, I'm just going to say, I like car, motor, tire. Okay. So let's just see. So initially it was 0.03, but now it's updated its weights. 0.28. See that? There we go. So I essentially, right? You guys agree? It switched it again? Ah, okay. Okay, so it's even higher then, right? So it was 0.03 and it's now 0.7, right? Okay, fine. So yeah, so I'm what? Something else? Yeah, but what they're saying is that it reorders them. So yeah, that's a tricky one. You probably, just to be on the safe side, have a list. Grab these, find out which position has the word that you're looking for, and then plug that index in so that you don't make them. I see what you're getting at, and it's a good because I'm saying to use this as a reward model, you have to always focus on that one word that you're trying to maximize, right? So we we started with smoking, but we decided we wanted to make it more to talk about cars. And so, but then it's moving it around. Now there may be a flag in there somewhere where you tell it not to move. That's also a possibility. But if you use this one, right, just make sure that when you're selecting this, always look at the 3 words in the labels here. Make sure the word matches what you're looking, find what index that is, and then plug that index in here. And that way your reward function will work. Yes, sir. Yeah, yeah, exactly. Like the order and the structure. So again, I'll repeat. The key thing is, because I've seen students that um, didn't maximize the correct one, right? So you're maximizing this value from 0 to 1 for that particular thing that you're trying to convert your GPT into, okay? So anyway, here I've shown 2 examples of rewards. One that's just like predefined, which is like the sentiment analysis, positive or negative, or this one called zero shot, which uses a little bit of these prompting ideas, and you can define the actual class that it produces. Okay, so it gives you a little bit more room, and then you just focus on that one word. Got it, guys? Any questions on this? And as I said, I'll come back to this, obviously, but this is one part of that whole RLHF discussion. Everyone with me? All right, great. So now on the last 25 minutes, or I guess I only have 15 minutes. In the last 15 minutes that I have, I wanted to talk a little bit about DeepSeek and what it is, just to point out some of those materials so you guys can look at it. So let me